Hello everyone, my name is Tian Feng, and I'm going to give a presentation for my DR project, Design Strategies on the Open Public Space of Affordable Housing from the Perspective of Carbon Emission Reduction. For this dissertation, I mainly want to give the answers to two questions. First of which is, will open public space bring more carbon emission to affordable housing? The answer is no, and the comprehensive carbon emission data I calculated in this project will prove this idea. The second question is, how to design low-carbon open public space in affordable housing? To answer this question, I will give some design suggestions based on the carbon emission reduction and also the needs of the low income. The whole dissertation includes 9 chapters. To make it simpler, today I will divide it into 6 parts, including introduction, the affordable housing and the low income, comprehensive carbon emission of different situations, prototype researches, design suggestions, and my own design. Let's start from the introduction. There are some key definitions of my project need to expand. First one is affordable housing. This is a specific housing type offered to the low income, and the low income group is defined by the regulations of Shanghai. Open public spaces refers to the open roof, open vertical garden, and open ground floor. They are basically in-building public spaces that are not completely enclosed on all sides. The carbon emission I estimated in this project is comprehensive carbon emission, including both physical and social parts. Physical carbon emission is based on architecture data, and social carbon emission is about the carbon emission caused by people and their way to outdoor activities. Here is a frame of the project. Some background research is a base, and then I've done the carbon emission simulation of a specific building with different open public space situations. This part is aimed to find out the relationship between open public space and the carbon emission change they caused. And after that, I have done the simulation for different prototypes of the open public spaces. This part is aimed to find a balance between the shape, carbon emission, and also practical use. Based on above data, some design strategies are put forward and then applied to my own design of affordable housing community. The second part is about the affordable housing and the low income. To better understand the living situations of the low income, I have done some comparisons between affordable housing and commercial housing, including the area of public space, actual status of the existing building space, and the distribution and usage of open public space among different income levels. The comparisons show that the public space in affordable housing is limited and the status is bad. Most affordable housing has no open public space, but nearly all the residents are willing to have. Then, I did some case studies all over the world. These are some good experimental affordable housing projects. They all have open public space, and I do research on how the open public space is like and how they serve the low income. It can be found that most of the open public space are well used by residents, and they mainly meet the basic material demand of the low income and also demonstrate their necessity. After that, I also studied the characteristics of outdoor activities of the low income, and also analyzed what kind of open public space can meet the outdoor activity needs of the low income. This will have impact on social carbon emission. And then I will go through the third part. This part is the calculation of comprehensive carbon emission of a building with different open public space situations. The physical calculation is based on life cycle assessment in 3 stages: construction, use, and demolition. The material production, building construction, carbon sink, and building dismantling are calculated by carbon emission factors. The operation and maintenance part is simulated by PKPM PBECA. Besides, the data is revised by the actual electricity data of 10 affordable housing. This step is essential, as the living habits of the low income is different from the other groups. Then we come to the social part. I collect travel activities data from 237 low-income families by questionnaires. The frequency and duration of different travel types for their unnecessary activities, and also trip intensities are collected. The substitution of open public space for the travel behavior of sample families can also be calculated by setting control questions. And this number is 73%. Then, social carbon emission can be calculated, and here are methods for social carbon emission reduction calculation. And this data is highly rely on the area of the open public space. After finding out the calculate method, I choose a building in Shanghai as a model for calculation. And then build 42 different models for different situations of open public space, the different area of different kind, and also different structure type of the open public space. Then, the comprehensive carbon emission under different situations can be obtained by adding physical and social carbon emissions. The following conclusions can be found. Firstly, considering the roof type, planting roof is more energy saving than accessible one. Secondly, physical carbon emission is directly proportional to the area of open public space. Thirdly, under some condition, the physical carbon emission increment of the open roof is the lowest, while the open vertical garden is the highest. Fourthly, social carbon emission reduction is proportional to the area of the open public space. When the operation time added in estimation, we can easily find that, in long-term operation, social carbon emission reduction is more obvious than physical carbon emission increment. So under this context, creating open public space can not only improve the life quality of the low income, but also have positive impacts on the comprehensive carbon emission reduction. Now, we are coming to the fourth part, prototype of the open public space. In this part, I will talk about the different shapes of the open roof, open vertical garden, and open ground floor. Try to propose some suggestions to keep a balance on carbon emission reduction and practical use. Let's start with open ground floor. I did the function analysis at first to see what kind of activities this space can hold. These functions are conducted from case studies and also my own observations. To calculate and compare carbon emission change of different prototypes, I set a model to control variables. It's a 14-story building with a story height of 3 meters, a standard building plan of 12 meters multiplied 32 meters. The open ground floor is 2 floors height and takes an area of 1/3 of the standard plan. These are the 14 prototypes of the open ground floor. For carbon emission, monoblock has better emission reduction potential. For function, a design that can pass through from one end to another is essential. Therefore, put a whole block in the middle with corridors around, or put to one end are both excellent choices. The similar research is also done to open vertical garden, the function analysis, and also the shapes. The open vertical garden is also 2 floors high and takes an area of 1/3 of the standard plan. For carbon emission, monoblock has a lower figure than the scattered one. For function, corridor-like ones have lower capacity. Therefore, when doing shape design for the open vertical garden, it's essential to put the whole block along the border. Last one is the open roof, the function analysis, and also the shapes. The open roof also takes up half of the space. For the open roof, as its surface area stays stable with different prototypes, the shape change has no impact on its carbon emission. Based on it, when doing the open roof design, activity carry capacity should be paid attention to, which means that band shape design should be avoided. Part 5, Design Strategies, is like a conclusion part of all the research I have done above. Like transfer the data conclusion into suggestions. The strategies can be divided into 3 main parts, from physical, social, and comprehensive aspects. And the last part, U community. This is based on those design strategies. Here is the basic information of my design. And this is a site plan. This diagram shows the basic atmosphere around the site. Based on the surroundings, I summarized the features for the 3 sites and set some expectations for my design. From the northwest to the southeast, I try to make the site atmosphere from private to public, and the height from high to low. It has 2 benefits. Different levels of public space can cater to different activities of the low-income groups, and it's a response to the atmosphere and building height of the whole block. This group of diagrams shows how the design comes. After mass formed, open roof, open ground floor, and open vertical garden are gradually set up, and finally form a complete open public space system. This is a bird view of the U community. And this is a ground floor plan. In northwest to southeast direction, a small number of openings are adopted for the courtyard connection. In northeast to southwest direction, the ground floor is open to keep the view of rivers unobstructed. For second floor and above, I chose standardized design and proposed 6 core layouts and 4 room layouts. They can be combined randomly under this column grid. In addition to the transportation function, the core is also a public activity area for the residents. These are room layouts. Here is a section. And then I want to talk more about the open public space system in this design. First, all roofs are used as open roof except for the northwest end, because when apply as much open roof as you can, the carbon emission reduction can be maximum and the need of the low income can be met. Here are some renderings. Open vertical garden proposal is the smallest. This is because its physical carbon emission increment is the largest, but the practicability is the weakest. These are the renderings. In this design, the area of open ground floor accounting for about 1/3 of the projected area, and the open ground floor is arranged as whole blocks to minimize the physical carbon emission. Here are some renderings. This figure shows the renderings and where they are. To verify the carbon emission change of this new design, I also built another model without all open public spaces as a control. Results can be seen on this page. Although the carbon emission will slightly increase at the beginning, the diagram shows that the figure will go to an opposite direction with time passing by. This trend is a great proof to the previous research that, when applying adequate open public spaces, the carbon emission will reduce in long-term running. And this is the end of my presentation. Thanks for your listening.